What's up, everybody? Welcome to System Crafters. I'm David Wilson, and today we're back with another entry in the Learning Emacs Lisp series, and we're going to talk about how to create a custom minor mode in Emacs. So what we're going to do is talk about Emacs concepts of modes, and then we're going to walk through some practical examples of how you can create a custom minor mode. And to do this, we're going to be continuing with the dotcrafter.el project that we started working on earlier in the series. Basically, the point of this project is to make it easy for you to manage your configuration files that are written in org mode and maybe any other auxiliary configuration files that you have that don't belong in org mode files. So right now we have the full functionality we need for managing our .files configuration for those org mode files and for those individual files that need to be symbolically linked back into our home directory. So the minor mode that we're going to be creating today will allow us to automatically tangle our org-based configuration files every time we save one. We make an edit to it and save it, and then it will link any of those new output files from the org file back into our configuration, or into our home folder basically, so that those configuration files become active. We'll also be able to set up a custom key map for any of the dotcrafter commands so that you will be able to have bindings already for them, or you can rebind them yourself if you want to. And those bindings will only be activated when the minor mode for dotcrafter is turned on. All right, so first of all, let's talk about what a mode is. And I think I've got some prompt here from EXW. Let me get rid of that if I can. Okay. Yeah, this thing won't go away. Anyway, much of the user-facing functionality in Emacs is provided by major and minor modes. So a major mode is the main mode for a buffer, and there can only be one of those running at any given time. So think of that as the mode for the file that you're editing, like an org mode file, or maybe an Emacs Lisp file that would have Emacs Lisp mode. So there's only one that can be active at any time, and if you try to change that mode, it's not going to add a new mode to the buffer, it's just going to change to the new mode that you've selected. To contrast that with a minor mode, which provides supporting functionality either in a specific buffer or globally in Emacs. So this is basically additional functionality you can turn on that provides you with some extra benefit, and you can have multiple of these minor modes running at the same time, either globally in Emacs or in a specific buffer. So this could be something like autofill mode, where you have a text editing buffer and you want the text to be filled or wrapped basically after a certain column number, like 79 or something. And you can turn this mode on for a particular buffer, and then this behavior automatically gets used in that buffer, but not in other buffers that don't have autofill mode turned on. So you can have this globally or locally in a particular buffer. So both major and minor modes can enable certain types of functionality when they're activated. So like we mentioned before, you could have a key map that's only active when the mode is enabled. You can also have some kind of mode line indicator to say that that mode is turned on. So for major modes, that's going to be just the mode name in the place, like right here where you see org down here in the lower right-hand corner of my screen, because I use Doom mode line. It tells you which mode you're using currently. But also for minor modes, there's something called a lighter. I don't know why they call it lighter, but that's the name for it. And that allows you to see which minor modes you currently have enabled. So in Doom mode line, since I have minions mode turned on, you don't see these by default, but since I just turned it off, now you can see that we have a lot of different lighters here, and these basically indicate what minor modes I currently have active right now, either globally or in this buffer. So I'm going to use minions mode to turn that back off again. Also, a major or minor mode can have a hook that gets executed whenever the mode is activated or deactivated, so that other functions or modes can be turned on or turned off along with that mode that you are you're developing, basically. Which is pretty useful, because oftentimes you'll want to, like for a major mode, like let's say org mode, whenever org mode gets activated, like you open up an org mode file, you want to run some functions that happen after that buffer gets loaded to add hooks or to turn on, turn off certain functionality. So basically any mode well, typically any mode will have a hook that you can attach functions to so that whenever that mode gets activated, you can run some code. And then a mode will also have arbitrary code that gets executed when the mode is activated or deactivated. Now, this is different than a hook because it only gets run at the time that the command for turning on or off the mode gets run, but it usually is for configuration of either the buffer or global Emacs based on the state of the mode at that point in time. So any mode that's defined will have a command that enables it or disables it that can be invoked either interactively by the user using meta-x or key binding, or through Emacs Lisp. So I've got a couple examples here to show that. So you can obviously run meta-x to get the command list and run org mode directly to change a buffer to an org mode buffer. That's selecting that minor mode. Or you can use Emacs Lisp to call the function for the mode, and typically what the convention is that you pass a positive number for, well, anything that's not a negative number turns on the mode, and I think a negative number turns off the mode. So it's a very weird distinction there, but I think it has to do with prefix keys and universal arguments. But the idea is that you can turn this on in Emacs Lisp just the same. You often see this happening in your configuration when you want to turn on a particular mode. You will either call auto revert mode or pass in a parameter to it to turn it on. Typically, mode functions also have the behavior that if you don't pass in a parameter, it will toggle the mode depending on how you call it. So we'll talk about that in a little bit. Okay, so let's talk about how to write a basic minor mode. A minor mode is basically a bit of Emacs Lisp code that conforms to a set of conventions on how minor modes should be defined. So you're going to see that a minor mode is actually very simple, and you can do it all from scratch yourself, and it doesn't really require too much code. So here are the high-level things that a custom minor mode needs to work correctly in Emacs. First of all, you need a variable for the mode that ends in dash mode, like dotcrafter-mode. And this variable basically indicates whether the mode is currently active or inactive. If the variable is set to nil, then the mode is not active. Wait, the way I wrote this seems a little bit weird. This variable we set to nil when the mode is not active, or any other value to indicate that it is active. Okay, so basically, if the variable that you created for your mode is nil, that means it's off. Any other value means it's on, basically. And if the minor mode is meant to be buffer local, then you need to use the make variable buffer local function to make that actual variable buffer local, so that the value for that mode being on or off is constrained to a specific buffer and not globally in Emacs. You also need a command for enabling and disabling the mode, which has the same name as the mode variable. And if you remember back from, I don't know, maybe the first or second episode in this series, we said that Emacs Lisp has separate namespaces for functions and for variables. So this allows us to have a variable and a function with the same name because they don't refer to the same thing. So the convention is that for a minor mode, you would want to have the variable name be dotcrafter-mode and the command also be dotcrafter-mode. So the command should accept one optional argument which indicates whether the mode should be enabled or disabled. Typically the value of t for true, or a positive number to activate the mode, or a non-positive number or a negative number, basically 0 or less than 0 to deactivate the mode. And whenever you omit that optional parameter, we basically assume that it means the mode should be activated when the function is called in Emacs Lisp. So if you call it in Emacs Lisp, you should always turn on the mode if you don't pass an argument. Or if you invoke that mode interactively, like through meta-x, it should be toggled. It should be turned on or off based on the current state of the mode, which it does make writing one of these commands a little bit more complicated because you have to take these different cases into account. So also, if desired, you can create a key map for the mode that can be enabled when that mode is turned on by adding an entry to the minor mode map alist variable, which registers that key map for that mode. And if we go and look at the documentation for minor mode map alist, we'll see a lot of junk here because this is key maps for all the modes, but the documentation says it's an A-list of key maps to use for minor modes. And if you remember what an A-list is, it is a list of pairs of key values. So if we look at this, let's see if I can find a good example. There's a lot of junk in here. So this is a list. We have the outer parenthesis, and then we have the inner parenthesis for org present mode. This is actually const with a key map, basically, but you can't tell because of just the way the printed representation looks. But basically, it's a list containing const pairs of key being the symbol for the mode, like dotcrafter-mode, and then the key map variable that holds the key map for that mode. And basically that means that whenever you turn on that mode, that key map will be active, and when you turn off the mode, the key map will not be active anymore. So it's kind of useful because it means that the user will only get your key map, your key bindings basically for your mode, whenever they turn your mode on. So it's a way to not pollute the global key binding space whenever you whenever you write a package. You don't want to pollute the key bindings for the users, so you can hide them behind your mode so that they only get activated when your mode is turned on. Also, if you want, you can add a lighter for the minor mode, which is basically that word in the mode line that we mentioned before, by registering it with the minor mode A list. So similarly to the minor mode map A list, there is a minor mode A list, which is another A list where you have pairs of the symbol for the mode plus the string to use in the mode line. The interesting thing to note here is that it doesn't have to just be a string. It can actually be a little bit more complex than that. It could be any valid mode line expression. So that means not only can it be a string, it can also have sections where things get evaluated, like here for smart parens mode. It can also be propertized text, which we really haven't talked about yet, but the idea being that you can change the face of the text that gets displayed in the mode line for your mode. So you have some customization flexibility there whenever you start displaying things in the mode line with your minor mode lighter. And finally, the command that is used for enabling and disabling the minor mode can then make whatever changes that are needed to the buffer local or global state of Emacs to enable the mode's behavior. So basically what I'm saying here is that the command, when you run it, you have to change the state of the mode, and then you can run any arbitrary code that sets up Emacs or that buffer that the mode is active in to do whatever behavior your mode is supposed to do. So we should also say that the mode command will have to check the mode variable to see if it's enabled already before enabling or disabling the mode functionality. So it's on you to, your responsibility to check to see whether that mode is actually on or off before you start doing things with that mode behavior. So let's create a simple minor mode from scratch. We're going to follow conventions we just talked about and write a simple minor mode from scratch. And we're going to create a mode called dotcrafter basic mode. So we're just creating a basic minor mode, basically, that will only set a key map that will be used when the mode is active. And then it will also update the mode line to have the string dotcrafter to indicate that it's turned on. So we've just got a snippet of code here we're going to look at. So first of all, we are defining that variable for dotcrafter basic mode. So the name of the mode, we're going to define a variable for it, and we're going to make it buffer local. So you can do this nice little sort of optimization, I guess you could call it, where you define a variable, but you can also wrap that in make variable buffer local, so that at the time this variable is declared, it gets made buffer local, so that it's only activated per each buffer. We're also going to define a variable for the mode map, so the key map for that mode. So we're calling it dotcrafter basic mode map, and we're going to call the make sparse key map function, which creates a key map object that you can use to define keys. Haven't really talked about this yet, but don't worry too much about it. We'll talk about it later in another video. But that gives us a key map to use for this mode. We're also going to define a key in that mode map, basically, that calls a function that writes out a message, dotcrafter key binding used. And the key binding is going to be Control-C, Control period, and then T. Then we are going to register our minor mode with the minor mode A list and minor mode map A list. For the minor mode A list, the strange thing is that even though it says it's an A list, the actual values in the list are not A list. They're not const pairs themselves. They're actually lists. I don't know why that's the case, but this is how it works for this particular A list. So we're using add to list to add an entry to minor mode A list. Note that we're using a symbol here, not the actual variable name. This is the convention to use for this function. And we're adding a list containing the symbol for the mode, dotcrafter basic mode, and then the string to use in the mode line. Now, typically you see they put spaces before the name that's used in the mode line. I don't know why that's needed. I would think that the mode line would generate spaces between the words, but apparently that's not the case. Maybe it's because there's some cases where you might want to have things that don't have a space between them. But just keep in mind that you'll have to put a space here more than likely. For registering the minor mode map A list, we're going to do a cons pair. We're adding a cons pair to the list, which pairs together the symbol dotcrafter basic mode with the actual value of the dotcrafter basic mode map. And then we're going to define a function for a dotcrafter basic mode, and we're going to set it to interactive because we want this to be an interactive function. We have an optional argument, which is sort of what we said before, where you need to be able to call this function without passing an argument. And if you call it interactively, what we're going to do is send the value toggle by default if you don't pass a value for arg. Excuse me. So when we talked about interactive commands before, I don't think I knew about this list syntax, but this is actually something you can do to provide a default value when running interactively. So in this case, we're going to pass in the value toggle whenever the user calls us interactively and there's no value that's being passed for that optional argument. And we're also, we're going to set the value for dotcrafter basic mode, but we're going to use this expression to set it. So what we're going to do is check to see if an argument is equal to toggle. So if that default value of dotcrafter basic mode in interactive execution isn't passed, we're going to default to toggle. So in that case, we're going to basically reverse the value of dotcrafter basic mode. So if it's currently true, we're going to make it false. And if it's false, we're going to make it true. We do that by using the not function. So not basically just reverses the Boolean value of any particular expression. So if I were to go into the echo area here with alt colon and say not t, it returns nil. If I use not nil, it returns t. So basically we're just reversing the value of whatever is there. So that allows us to toggle the value of dotcrafter basic mode. Otherwise, if arg is not equal to toggle, we check to see if arg is greater than 0, because if the value is greater than 0, then we're going to turn on the mode. If it's 0 or less, we're going to turn off the mode. So basically we just use a single expression to set the value of dotcrafter basic mode based on the expectations for how the mode function or mode command should be operating. And then we're going to run some arbitrary code to check the state of the mode to see if it's on or off, and we're just going to write a message to say that the mode is activated or deactivated based on that state. So let me go ahead and just run all of this so that we can see how it works, and we'll see if eval region cooperates with me here. Okay, so now I've evaluated all this code, and I should be able to run dotcrafter basic mode. So when I run this interactively, it's going to tell me that dotcrafter basic mode is deactivated. I think that I don't have it set up correctly from the start. I think what I should have done here is set the default value to nil. That would have made things a little bit better. If I rerun this, it probably won't work right. But anyway, let me turn off minions mode so we can see the lighter in the mode line. So I'm going to run dotcrafter basic mode one more time. And now you'll see dotcrafter shows up here. We also got the message in the echo area, dotcrafter basic mode activated. So now we see our lighter, we see dotcrafter basic mode activated, and we should be able to use the Control-C, Control-T key binding. Let me turn on keycast mode actually. So Control-C, Control-period, and then T. So now it says dotcrafter key binding used. We see that our key binding here actually maps to this lambda that we put directly in. So everything for our basic mode map seems to be working correctly. We can go look at the variable for dotcrafter basic mode map to see what it has in it. It's not happy at the moment. Let's see if I can pull it from somewhere else. Dotcrafter basic mode map. For whatever reason, it doesn't like my mode map and it doesn't want to show the information. If I use describe variable directly, let's see. Okay, that one works. All right, so we see the dotcrafter basic mode map has a value of a key map that has basically just the keys for the necessary key binding, and then it binds to that lambda at the end. So we can see that that's a variable that you can go and use define key to set new bindings for that mode if you wanted to. Now, what else? We'll check the value of the dotcrafter basic mode map. I think the helpful mode is giving me trouble today for some reason, but let's use describe variable for that. So dotcrafter basic mode Its value is toggle.crafter-basic-mode. That doesn't make sense. Oh, okay. I think that's the reason why. I have my code set up incorrectly here. This should be... I should take this out. Let me just check that really quick. Init value docstring. I think, yeah, that's what happened. The first time that I ran this, I'm going to use Control-Alt-X to redefine this variable, if it lets me. Control-Alt-X. Yeah, oh, it's undefined. So basically, the problem here is that the first time that I ran this def var, I didn't have nil here. I actually only had the docstring, so it created the variable with the default value of this string and not the nil that it needed to be. So that was my mistake here. But I think we're okay because the buffer local value of this should be set correctly at this point. What else do we need to look at? I think that's it for this. So that's all you need for a basic miner mode. This is like a command function you define and a variable, and if you want, you can do the mode map and then registering things for the miner mode A list and miner mode map A list. So it can be very useful if you wanted, even for your own configuration, to have a set of key bindings that are only turned on at a certain point in time. You could use a miner mode for that if you didn't want to use some other approach. So it's very easy to write your own miner mode. So let's note that this doesn't perfectly follow all of the conventions for writing a miner mode, though. Miner mode commands typically should also accept numeric prefix arguments for controlling whether the mode gets enabled or disabled, but it's not a hard requirement. So I think we talked briefly about this in the defining commands video, but if you use the control U universal argument, you can press that a couple of times to get a numeric argument, basically, or you could even control U and then type a number to get a specific numeric argument to pass into a command that you run next. So for whatever reason, this is a convention where you should be able to accept a numeric prefix argument for your miner mode to turn it on or off. I don't know how many people actually use it like that. If you use numeric prefix arguments to turn modes on and off in your configuration or in your workflow, definitely let me know in the comments, because I don't use it like that, so I don't really know why that turned out to be a thing, but apparently some people do. If you want more information on the conventions for writing miner modes, which is basically a lot of what I just told you, check out the Emacs Lisp manual, this link here in the show notes. All right, so let's talk about one other useful thing that you can do whenever you create a miner mode, and that is to create a hook. So a hook is a variable that stores a list of functions to be invoked when something happens, like when a mode is activated. So you're probably familiar with the idea of hooks if you've written parts of your own Emacs configuration and you wanted to hook one mode to another mode. So now we're going to figure out how to write your own hook. And doing this is really easy. Basically, you just define a variable that's set to nil or an empty list by default. In this case, we're creating the dotcrafter basic mode hook. The default value is nil, and we say that it's the hook for the dotcrafter basic mode. I'll go ahead and evaluate that. And if you want to run all the functions that are attached to a hook, you just use the run hooks function, and you pass it the symbol for the variable name for your hook function, not the variable itself. That's just the way that this function operates. So if I were to run this, it doesn't really do anything because we haven't registered any hooks yet. So we need to add a function to the hook using the add hook function to register a hook function on that hook. So right here, we are adding a hook to the dotcrafter basic mode hook. We're using a symbol here. And then we're just going to pass in a plain lambda to say that we're going to write a message saying the hook was executed. So I'll go ahead and run this, excuse me, and we can take a look at the value of dotcrafter basic mode hook just to double check that it has a hook registered. So dotcrafter basic mode hook's value is that lambda function that we just registered. And you can have any number of functions added to this hook variable. It's just a plain list of functions. So now if we use the run hooks function, we can see that it will get executed. So if I run this with Control-X, Control-E, you probably saw the message flash there for a second, but I'll use Control-H-E to pull up the messages list. And it says here that the hook was executed. So it definitely did run our hook function that we had registered. All right, so now we're going to update the basic miner mode that we wrote to invoke this hook whenever the mode is activated or deactivated. And this is the same command that we looked at before. The only thing we're doing differently now is we're just using run hooks at the very end to run our dotcrafter basic mode hook. So I will execute this code to redefine that command. And then I'm going to run dotcrafter basic mode. And you can see now it says the hook was executed. If we go and look at Control-HE to pull up the messages buffer, we ran dotcrafter basic mode. It says dotcrafter basic mode was deactivated and the hook was executed. So we can definitely see that the hook is executed in that case. And if you want a simple basic mode that has a hook, that's basically all you need. It's not really that complicated. One thing to note though, we're not talking about major modes yet, but I did want to point this out, that major modes should use the run mode hooks function instead of run hooks whenever you are writing a major mode. There's extra logic that gets used in major mode hooks. There's some extra things that need to be done for like directory local variables and file local variables and some other stuff that needs to happen there. So if you're writing a major mode, use run mode hooks instead. But otherwise, minor modes or any other case where you want to invoke hooks, just use the run hooks function. Okay, so up until now, we've seen how to define your own minor mode from scratch. And it's useful to learn that because you get to see how simple it really is. But once you understand how they work, you don't really want to have to define all those variables every time that you want to create a minor mode. So there is a much easier way to do this in Emacs, and that is the define minor mode macro that basically makes all this stuff easier because it creates a macro that defines all these variables for you and also implements the conventions that are expected from a minor mode command. So let's look at another example of defining a mode called dotcrafter-mode that is exactly like the one that we defined before, except for how it's defined. So now there's a lot less code here. We see that we are using the define minor mode macro, and we are saying we are defining a mode called dotcrafter-mode. So we just give it this symbol name here directly, dotcrafter-mode. We have a documentation string here that says we're toggling the global dotcrafter mode. So one difference here is we are actually creating a global mode instead of a buffer local mode this time. Now here are some parameters that actually are special to this. So first of all, we have nil, which is the initial value for the mode, and we're just saying nil because we want it to be disabled by default. We don't want it to be enabled by default. We're also using this keyword parameter global, setting it to true to say we do want this to be a global minor mode. And the thing to note here is that when you create a global minor mode, what the macro does under the covers is instead of using def var to create the dotcrafter mode variable, it's actually using def custom, because the idea is that for a global minor mode, the user may want to use the customization interface to turn that value on or off. So we're going to use def custom instead. So that's why we also see group here, because since we are using def custom to define a custom variable for this mode, we want to set the group for this as well. So we're setting it to the same group we're using for everything else in our dotcrafter package, which is the .files symbol to say this is the .files set of functions and variables. We can also use the keyword variable lighter or parameter lighter to set the lighter string. So that makes it a lot easier. We don't have to go mess with the minor mode A list ourselves. And we can also use the key map keyword to set the list of key bindings for this, the key map for this mode. So in this case, excuse me, we have a list of cons pairs, and we are setting the keyboard string here for the same key binding, Control-C, Control-T, and then we are passing in a lambda that basically says the key binding is being used. And that's how we set up our key map. We don't have to set up that minor mode map A list. We just use it here. We set this parameter basically, and then it does it for us. And then finally, we have the body of the minor mode command. So this could be any arbitrary code that you want. So in this case, we're checking to see if dotcrafter mode is turned on, and we're writing the message saying it's on. Otherwise, we write a message saying it's off. And as you see, we didn't do any of that other logic to check to see what the parameters were. The define minor mode macro wrote all of that code for us, so we don't have to do it. So the other thing that it did is it created a hook for us. So it creates the dotcrafter mode hook, and then it runs it after, I think it runs it after the body of the minor mode function. So we can actually add a hook to that and test it out. So what we're going to do now is evaluate this code, Control-X, Control-E. We're going to see a lot of output, but that's mainly because it's showing the value of the minor mode map A list to us for some reason. I don't know why it's writing that out, but Now we've defined a minor mode called dotcrafter-mode. If I were to run dotcrafter-mode, the command, we see that it's here now. It says that it toggles global dotcrafter mode. I'll press enter on that, and it tells me dotcrafter basic mode is activated. So we also see the lighter is now here. And if we were to use the Control-C, Control-T, it says dotcrafter key binding used, which is the same message that's here. We can also check the dotcrafter mode hook. We haven't registered this hook yet, so we'll probably see that it's empty. So dotcrafter mode hook, the value is nil right now. I can register this hook and then turn off dotcrafter mode, and we'll see hook was executed. And that's because we're running the hook regardless of whether the mode gets turned on or turned off. You may think this is weird. Maybe it should only run it whenever the mode is turned on, but I think it makes sense to run it in both cases, because maybe the person or the hook function that is being called from that hook wants to check if that mode is turned on or off and do different behavior based on whether it's on or off. So it makes sense to call it in every case. So if we run that mode again, we'll see that the hook gets executed again and dotcrafter mode is back on. So that's way less code. We don't have to worry about the ins and outs of defining a minor mode. We just know what stuff we want our minor mode to have. I think that the lighter is not necessary, the key map's not necessary. So if you only wanted something very simple, it's only maybe 5-6 lines of code. So that's pretty nice. So let's take a look at a couple other things really quickly. So obviously we get the dotcrafter mode command, which we saw. We get the dotcrafter mode variable, which stores the state of whether it's on or off. We get our dotcrafter mode hook. However, we also get a couple other hooks which are kind of nice. So like I said, the dotcrafter mode hook gets executed every time. However, there are special hook functions called on hook and off hook that get generated for your mode symbol name. So in this case, dotcrafter mode on hook. I don't think these variables get defined, but if they exist, then basically, if anyone registers a hook to those variable names, then they will get executed. So let's actually try this really quickly. I'm going to add a hook for dotcrafter mode on hook, and then we'll say dotcrafter turned on, and then we'll do one for off hook as well to see if that works. So off hook turned off. I will evaluate both of these. And now I'm going to run dotcrafter mode, which should turn it off. And then it says dotcrafter turned off. If I run it again, it says dotcrafter turned on. So basically, this is a convention that is established for any minor mode that's defined with this macro, where you have dotcrafter mode on hook and off hook that are created. You don't see variables for these by default, but if someone does register a hook on those variables, then it will get invoked whenever the mode gets turned on or off. Yeah, so we also got the mode map, so we can check that variable. I don't remember. Did we check that one already? Let's see. Dotcrafter. Let's see. Describe variable dotcrafter mode map. And we do see that it does have a key map there. So we didn't have to create that key map at all. We just had to know what key bindings we wanted to set there. And that's basically it. We can take a look really quickly also at the dotcrafter mode command, just to see what the source has in it, the generated source. And it's kind of complicated because there's a lot of things that it does. It's doing the checks for the prefix arguments, some stuff about last message, not sure what that's about. Setting default values for the dotcrafter mode, setting the information about minor modes. It's writing out some information about whether it's enabled or disabled. It's forcing the mode line to be updated, which is kind of interesting because if you put something in the mode line that needs to be evaluated, then we want to force that update so it does get evaluated and displayed. Yeah, so there's a lot of extra stuff here that we wouldn't know about. We wouldn't know that these are things you might want to do in a minor mode, and we're getting that behavior for free, so that's kind of nice. There's also more information on this macro in the defining minor modes section of the Emacs Lisp manual if you want to check that out. All right, so now let's look at our final example, which is writing real behavior for dotcrafter mode. So we're going to take what we've learned so far in this episode and set up dotcrafter mode so that we will automatically tangle and update configuration target files for any org mode file that lives inside of our .files folder. So basically the idea is that whenever you turn on dotcrafter mode, it's going to set up some hooks so that whenever you edit an org file that we know about, that we basically said this org file is a configuration file in our .files folder, upon saving changes to that file, we want to automatically tangle the output so that the configuration files get written out. And then we want to link those files into our home directory if they are being written into our special folder of files that need to be linked. So we're gonna do a few more things than what we did in the examples before. So the first thing we're doing is we are defining a custom variable for the key map prefix for all of the key bindings in this package. So it's not very nice if you just start defining key bindings arbitrarily and maybe overwrite things that the user already has. It's good if you provide a way for the user to customize the prefix key for your own package's key bindings. So in this case, I'm providing a customizable variable that by default says that our prefix for all dotcrafter.el key bindings are Control-C, Control-period. I chose a period because it's like dot for like dot files, and it's not very commonly used, so it seemed to be appropriate for this. Also, we're going to set up a variable called dotcrafter-tangle-on-save. It's going to be true by default, and this variable will determine whether when you save a file that we determine is a org mode configuration file in your dot files folder, if this is true, we will automatically tangle your file to its output files. Otherwise, we will not. So that allows you to turn on dotcrafter mode and have the key bindings available, but not have that automatic tangling behavior if you don't want it for some reason. We're also going to make a slight tweak to the dotcrafter-tangle-org file function that we already have, and that is just to add this dotcrafter link config files function call at the very end. Now, this is not the most efficient way to do this. I ran out of time when I was preparing this episode and didn't get a chance to write the full implementation of what I would prefer, which is to only try to link the files that are output files of the current org mode file. That takes a lot more logic, so I didn't do it right now. What we're doing is just naively calling that one function that links all the files that are in the output path. So that's not very efficient, but later we will fix that. Also, we are going to deal with some hooks here. What we're going to do is, I'll explain these in a second whenever I get to it. I'm going to also define a function called dotcrafter-key, which allows me to say for a particular key, I just want to add that key map prefix to it. It makes it easier for us when we start defining key bindings in our mode map. This is also an internal function not meant to be used by the user. You can tell that by the hyphen here. Okay, so now we're redefining the dotcrafter mode. Everything is pretty much the same up until we get to the key map section here. And we are defining two key bindings for this mode. One is the Control-C, Control-T, and the other is Control-C, Control-U. The first one runs a tangle org file, which would tangle the current file that we're currently at, or we're currently looking at. And then the U, which will update all of our dot files and do all of the relinking of files that are necessary to get our dot files up to date. So by turning on dotcrafter mode, we now get these two key bindings using that prefix that, that we set by default, and the user could also customize that to set that differently if they wanted to. Also, when dotcrafter mode is on, we are going to add a hook to org mode hook. So anytime an org mode file is opened, we're going to call this function dotcrafter org mode hook. So if we go take a look at that, that function adds an after save hook to the current buffer. So we're calling add hook, we're adding the dotcrafter after save handler, and we're passing these two parameters here to basically say, I want this hook to be buffer local for the current buffer. So when org mode hook gets fired because we open an org mode buffer, dotcrafter is going to add an after save hook to this specific buffer so that this after save handler function gets run every time the buffer gets saved. Now in this after save handler, what we're doing is, first we're checking to see if dotcrafter mode is on, because let's say you have a buffer open, or sorry, you turn on dotcrafter mode, you open an org mode file, re-register this after save handler. What if you turn dotcrafter mode back off after that? You don't want the autosave to happen anymore. So we're gonna check to see if dotcrafter mode is on before we try to do anything to automatically tangle the files. Then we see if tangle on save is turned on. And we're putting all this into one and expressions. We're saying, so long as dotcrafter mode is turned on and dotcrafter tangle on save is turned on, then we can go and look at the rest of the expressions and see whether we should do the tangling. Next, we're checking if the file name itself is one of the dotcrafter.org files. So for dotcrafter.org files, we have a list of files that say what our org mode files are for our dot files. In this case, emacs.org, desktop.org, etc. So we're saying that for the current file, we're looking at buffer file name, getting the non-directory part of the file, if you remember from the previous episode. Yeah. So we'll get the file name from this, emacs.org, and we check to see if it's a member of the list called dotcrafter.org files. And if it is, then we check to see if the path where that file lives is the dot file path, basically, because not only do we want to check if the file name is one of those config files, we want to make sure that it actually is a file that lives under the dot files path, because you could have emacs.org somewhere else in the file system and we'll mistakenly try to tangle that instead. We don't want to do that. So we'll use string equal here. We'll check the directory file names of both the buffer name, file name itself, and the dotcrafter.files folder. So we're making sure dotcrafter mode is on, making sure that we can tangle on save. The user has allowed us to do that. And we're also making sure that the file that we're tangling is a configuration org file that we know about. If all those things are true, we write on a message saying we're tangling the file, and then we run dotcrafter tangle org file for the buffer file name. And then that's it. We basically tangled the file. We've updated the symbolic links for any output files there. And we should be all up to date with that file after that point. So instead of running this code here, I'm actually going to go run the dotcrafter.el file that I've prepared itself, because I want to make sure everything is loaded correctly. So I'm going to use eval buffer on this file. Whenever this episode is posted today, this code will be on the dotcrafter.el repo, so you can take a look at it directly if you wanted to. So we've evaluated this code now, and I will turn off dotcrafter mode, and I'm going to turn it back on now. So this should enable our new behavior, where we have the org mode hook now containing the dotcrafter org mode hook. So let's just double check that is the case. So now we see at the very beginning of this list, we have dotcrafter org mode hook. So we know now that our new behavior is turned on. And I'm going to go over to, let's see, is anything open yet? Yeah, so I'm going to open my Emacs config file. So this is my emacs.org file. And if I were to make a change to this file and then save it, you can see now that it says tangling emacs.org. So we know now that our custom functionality from our minor mode is working. If I were to use Control-C, Control-T, then it says the dotcrafter key binding is used. I think that that binding hasn't been updated because we were using the same mode name. So I think that these didn't actually overwrite the mode map. Let me run this with Control-Alt-X to see if that does anything. Did I do anything? Control-Alt-X. Oh, no, that was Shift. My mistake. Control-Alt-X. Okay, hopefully that rebounded. So let me go back into this buffer again. Control-C, Control-T. Okay, so there's a bug actually in the dotcrafter tangle org file function where it doesn't actually pick the current buffer name correctly, but let's ignore that for now. We'll fix it at another point. Okay, and then so now it shows that we're working. Our hook is hooked. Our key bindings are working. Our hooks for our mode are working apparently. So now what we want to do is see if this actually does the intended behavior. So we're going to go and check our desktop.org file really quickly. So sorry for that, FDD. Okay, so .files. So I've already set one of these up to get written out to the files folder. I think it's xsettingsd. Oh, no, I haven't done it yet. Okay, so right now, this file gets written out to a local path called .config/xsettingsd. What I'm going to do is change this to the path that we've configured in dotcrafter to be like the auxiliary files path. So it's .files. And if you remember from the previous episode, that would be the, let's see, dotcrafter files. Yeah, dotcrafter config files directory. So this is the directory path inside of the .files folder where configuration files that should be symbolically linked are stored. And this is set to .files. So what I did is set this xsettingsd.conf to be written out to .files/.config. And since I changed buffers, my Emacs config is set up to automatically save, so it should have tangled already. We can verify that here. Yeah, we've done tangling of desktop.org. So now we can go check and see in my .files folder, in the .files folder, that config/xsettingsd/xsettingsd.conf is now here. And we can go check that in my output folder, or sorry, my home folder in .config, if we look at xsettingsd, that is now linked to my .files/.config/xsettingsd folder. So basically, just by setting this path here and saving the file, it automatically got tangled, and that file automatically got linked back to the home folder. We can double check this if we just copy this block and basically make up a new file. So let's say you added a new configuration file to your org file that you wanted to automatically be tangled and linked back into your home folder. We can make an xsettingsd2 folder here. So I'm creating xsettingsd2. I'm going to save this. And after the auto tangling is complete, I can go check the .files folder, go look in .files, look in .config, and now there's xsettingsd2. If I go back to my home folder and check config, check .config, then down here I should see xsettingsd2. So that automatically got linked as soon as I saved that file. So some of you are probably looking at this saying, why would I use this sort of .files situation where you have to do symbolic links if org mode can automatically write that file out to the home directory? That's true. Basically, the way I've set this up is that you could either have this be written out directly by using your home path, and then org mode will take care of writing that file out to the right place. Or if you would prefer all of your files to be symbolically linked, you can use the .files approach here. So it's up to you to decide how you want to manage your configuration files that are being written from your org mode files. So that's just your own personal preference. All right, so what else do we want to see here? One other thing we can see is that if we go to the readme.org file and I'm trying to make a change here and save it, it does not tangle this file. We can go look at the messages output and see that there was no tangling of readme.org, and that's because readme.org is not a member of that dotcrafter org files list. So that bit of the logic did work. Let's see, turn off dotcrafter tangle on save. Okay, so yeah, we can also set setq dotcrafter tangle on save to nil. And if we go back to our desktop.org file, make a change, save it, it no longer gets tangled because that variable is now set to nil. I can go reset that back to T and make sure that it does work. So now we see it's tangling one more time. And then if we turn off dotcrafter mode and then save the file, it also doesn't get tangled. So we've basically made it so that the user has a few different ways to turn off the auto-tangling behavior if they want to, or if the mode is just off, it doesn't do any auto-tangling. And it only does auto-tangling for files that we know about that are org mode configuration files in our .files folder. So at this point, we have a pretty nice behavior for automatically managing our configuration files every time we save and edit to those org files, which is great. So what's next? In the next episode, we're going to learn how to write a custom major mode that provides a simple user interface for the dotcrafter.el package. There's really not much you can do that would be a cool interface for this type of package, but we're going to try to make one anyway, just to show you how you would write a major mode and how you might, use your own custom buffer for doing some basic user interface display for a package. So that might be pretty fun. And it's also, we're getting to the point now where we're pretty close to having a package worthy of release. So in one of the next episodes, after the major mode episode, we're gonna try to clean up this package, put all the documentation strings in the right place, make sure that we pass the fly check errors for Emacs Lisp, and then we're gonna try to submit the package to Melpa so that this package can be downloaded by other people. So I'll show you how to go through that whole process to prepare your package and then submit it to Melpa so that anyone can install it. So we're almost at the point now where we've written a full package in the series and we're gonna ship it. After that, we'll just do various videos about different topics like maybe unit testing and different types of things you might want to do in Emacs Lisp. So we'll just get to have some fun and work on the package that we've already created. So I think that we've done pretty good at making something from scratch and showing how to do it in this whole series so far. All right, so before we go, I would just love to thank my sponsors. These people have decided to sponsor the work that I'm doing, making videos about GNU Geeks, GNU Emacs, etc. And I'm very thankful to them for their support. It really sort of inspires and motivates me to keep going when I know that people care enough about what I'm doing to support me in this way. So if you're interested in becoming a sponsor, definitely check out the links I have below in the description. I'm on both GitHub sponsors and Patreon. I also have a link to PayPal for one-time tips. And if nothing else, definitely just like this video, share it with people that you know who might be interested in Emacs and learning Emacs Lisp, obviously. And yeah, just keep coming and checking out the videos, because I just love being able to talk about the stuff with all of you, and be able to chat with you about it. So on that note, also definitely join the Discord. We have a Discord link in the description below. A lot of people there that talk about Emacs and geeks every day, so please come join us. All right, until next time, I think that's it for today. So until next time, thanks a lot for watching. Happy hacking. Thanks. We'll see you next time.